Okay, so next set of practice problems, we're asked to solve each system of equations, and notice that I have two equations here. Remember that in your directions or in your notes on the front side, we have 3 steps to solving a substitution method. The first step is to rearrange one equation to isolate a variable. We've already got both of these rearranged to isolate a variable. The second one is to substitute the expression that you have isolated into the other equation. So let's just say that this is my isolated expression and it's equal to y, so why can I not replace it with this y right here? So if I do that, what I end up with is 4x minus 1 is equal to 2x minus 5. And this is transitive property right here. If this is equal to y and this is equal to y, then these two things must be equal. So now I can solve for one variable. I don't have two variables involved anymore, just the one. So I can solve by subtracting the 2x. I can add the 1, and I end up with 2x is equal to negative 4, divide by the 2, and I get x is equal to negative 2. Now the next step of this is that once we have one of these variables, we plug it back into one of these equations. So I'm going to take y equals 4x minus 1, and I know that x is negative 2, so I'm going to replace it into this equation, and I'm going to solve for y. Now I have negative 8 minus 1, so y is equal to negative 9. So I have an x and a y for my solution. So since I have an x and a y, and an ordered pair is written in the format x comma y, why don't we put our answer as x, negative 2, y, negative 9. So our answer here is negative 2 and negative 9. That lets me know that x is negative 2 and y is negative 9 because it's as an ordered pair and they're always written x comma y. Now before we finish up, we do want to make sure that we check that both conditions have been met. So in the first one, negative 9 is supposed to be equal to 4 times negative 2 minus 1. And in that case, negative 8 minus 1 is negative 9. So that one is working. And then we have y here, negative 9 is equal to 2 multiplied by negative 2 minus 5. And so negative 2 times negative, or times positive 2 is negative 4, minus 5 is negative 9. So both conditions have been met. This is our correct answer. X is negative 2, y is negative 9. Alright, so another example we have here is y equals 6x and 2x plus 3y is equal to negative 20. So first step again is to isolate one of the variables. So I've already done that. Y is equal to 6x. So I'm going to replace the y in this other equation with 6x. So I have 2x plus 3, and instead of y, I'm going to use 6x. That allows me to have one variable and to be able to solve it. 3 times 6x is 18x. Add that together, I get 20x is equal to 20. I divide by 20, and x is equal, sorry, this is a negative 20. Negative 20 helps if I'm paying close attention to what I'm doing. X is equal to negative 1. Now once I find the negative 1, I can replace it into either equation. So I'm going to replace it into the first one. So y is equal to 6 multiplied by negative 1. So y is equal to negative 6. So what I find here is that my x is negative 1, my y is negative 6, and I need to check myself to make sure that that works. So I'm going to replace these two variables, or these two values, into the first equation. Negative 6 is equal to 6 times negative 1. That works, so the first condition has been met. The second condition is the second equation. So 2 times negative 1 plus 3 times negative 6 is supposed to equal negative 20. Well, 2 times negative 1 is negative 2, 3 times negative 6 is negative 18, and together that equals negative 20. So my correct solution is negative 1, negative 6. Alright, number 3. Here, again, we already have one of our variables isolated, so we're not having to do that. So I'm going to take this value and plug it in for y. So I have 3x plus 8 multiplied by x plus 9 is equal to negative 5, and I'm going to distribute the 8. So 3x plus 8x plus 72 is equal to negative 5. I'm going to combine my like terms. I'm going to subtract the 72. I end up with 11x is equal to negative 77, and I'm going to divide by 11 to get that x is equal to negative 7. Once I have the value of this number, I can plug it into either equation to find the other variable. So in this case, I'm going to do y is equal to negative 7 plus 9. So y is equal to 2. So I end up with the ordered pair negative 7 for x and 2 for y. Now I'm going to plug both of those numbers solutions into both equations to make sure that both conditions are met. So I have 2 is equal to negative 7 plus 9. That works. The second one is 3 multiplied by negative 7 plus 8 times 2 is supposed to equal negative 5. So this is negative 21, this is positive 16, and together that equals negative 5. So both conditions have been met. There are my solutions. Okay. Now, it's not always the y that's isolated, sometimes it's the x. So this time our x has already been isolated for us, so I'm going to take this value and plug it in for x this time. So 2 multiplied by 4y plus 7 minus 6y is equal to 12. So again, just taking that x out, replacing it with 4y plus 7 because x is equal to that. Then I can distribute. So 8y plus 14 minus 6y is equal to 12. I can combine my like terms. I can subtract that, and I get y is equal to negative 1. Once I have the y, I can plug it into either equation. I'm just going to plug it into the top one. X is equal to 4 multiplied by negative 1 plus 7. Negative 4 plus 7 gives me a positive 3. So I end up with 3 as my x and y is my negative 1. Be careful to write them in the correct order, x comma y. So now I need to check both conditions to make sure that they are met. So I should have negative 1 is equal to 4 times, sorry, I wrote it backwards. It's a bad thing to get in that habit. X, 3 is equal to 4 times negative 1 plus 7. So 3 is equal to negative 4 plus 7, which is 3. So that one works. And then we have 2 multiplied by 3 minus 6 times negative 1 is supposed to be equal to 12. So here we have 6. Negative 6 and negative 1 becomes a positive 6, and that equals 12 as well. So that works just like it's supposed to. Alright, so one more example we have. This one is another word problem. So in this case, Dustin has nickels and quarters in his piggy bank. He has 49 coins total for a combined value of $8.85. So here we have a relationship between nickels and quarters, and we have two conditions that need to be met. We need to make sure that they equal 49 coins total and a total value of $8.85. So I'm going to say the two things that I don't know here, my unknowns, are the number of nickels. So I'm going to call this N as my number of nickels, and Q, which is my number of quarters. You can use X and Y, there's nothing wrong with that. I just like to use those same variables just to kind of keep straight which is which. So how many of each type of coin does he have? That's what I'm looking for. These are my two unknowns. So the two conditions that need to be met. I know that he has 49 coins total. So that's the number of nickels plus the number of quarters totals 49. But I also know that the value of them is $8.85. And just unlike the previous example that we did on the front side where we had a point value for each of the multiple choice questions and a point value for each of the word problems, we have a value for each nickel and a value for each quarter. It's just not given to us in the problem. It's understood that we would know that. So we use the value of a nickel, 0.05, and multiply that by N, and the value of a quarter, 0.25, and multiply that by Q to represent the total value of what's in the piggy bank as $8.85. So now I have these two equations that I need to use. So the first thing I'm going to do is rearrange this one so that one of my variables is by itself, and it doesn't matter which one. So I'm just going to do N is equal to 49 minus Q, just subtracting the Q over there to the other side. So I'm going to replace in this other equation the N with 49 minus Q. So I have 0.5 multiplied, and instead of N, I'm going to use 49 minus Q because that's what N is equal to, plus 0.25Q is equal to 8.85. And then I'm going to simplify this. So 0.05 times 49 is 2.45 minus 0.05Q plus 0.25Q is equal to 8.85. I can combine those like terms. I end up with 2.45 plus 0.2Q is equal to 8.85. I can subtract that 2.45 and I get 0.2Q is equal to 6.4. Divide by that 0.2 and I get Q is equal to 32. So Q represents the number of quarters. So I should have 32 quarters. Now I can take that value and plug it into either one of these equations. I'm going to plug it into the top one. So n plus 32 is equal to 49. To find n, I just subtract the 32 and end up with 17. So if all of my conditions have been met appropriately, like they're supposed to be, then I should have 17 nickels and 32 quarters in my piggy bank. But let's double check. So first off, the first condition was that 17 nickels plus 32 quarters was supposed to equal 49, and together those equal 49, so first condition has been met. The second condition was that they had to have a combined value of $8.85. Well, it's a nickel for each of the 17 nickels and 0.25 for each of the 32 quarters, and we can add those together. So we end up with 17 nickels is 85 cents, 32 quarters is $8, and together that equals $8.85. So both conditions have been met. So my final answer is Dustin has 17 nickels and 32 quarters. And that's going to be my final answer. So there will be additional practice problems. If you need any help with them or have any questions or need any clarification on anything that we're working on, just make sure that you ask for that, and I will be happy to provide it.